Okay, it is time. Hello, everyone. I'm Bernard, and I'm gonna talk today about release management. So, why am I talking about a release management as such? Well, I'm running a software company for many years, and we develop our product. And while developing this product, we are, of course, find a lot of challenges, in about how we work, when do we release the new updates, how our team can work together, how we can all collaborate, and not the least important, how not to kill each other because we have conflicting changes in the different branches, we have conflicts in the code, we have code that gets overwritten by somebody and things like that. And this is why I have an inspiration to talk about release management. Let me share my screen. All right, so I guess everyone that is working in a big project, sooner or later, if things are not well organized, when he looks at the way how the source code evolved, how different branches are done, how different people are doing different things, more or less, code looks something like that. So it becomes totally chaotic. It becomes totally impossible to track when somebody did something and why. Now, my other inspiration for this talk is something else. As the software company, we do hire new people all the time, and yeah, what we realized is that all the young developers coming to work for us or coming to an interview have a great knowledge about C#, have a great knowledge about SQL or JavaScript and things, but have absolutely no clue about release management, about versioning, about source control. Nothing about that, because it seems like nobody is really teaching them that, nor they are interested to learn by themselves. Let me just tell you a funny thing that happened to us. Usually, when somebody wants to join our company, they have to make their intro project for us. So they get a very simple project, they have to solve it, and yeah, send it back to us that we see how the guys are thinking. And then we get the project, and the project is in two branches. One is version 1, one is version 2. I say, what the hell? Why do we have two different on GitHub? Why do we have two different projects? And then we look at the other projects that the guy who did the entry test quite good, how his other GitHub projects look like, and then you see the thing, and it says like test project version 1, then text project version 1.1, then test project version 1.2, then test project version 2, then test project 2.1, 2.2, 2.3. And I say, what the hell? Basically, you don't need then a GitHub for that. You could have just used the zip or something like that. Basically, even though somebody might be a good programmer, they don't know anything about either release management nor proper source control. So what is in fact release management? Basically, release management is complete process that basically ensures that we're going to deliver our product on time. So various things that we have to do in order to make sure that the project is going to be available to our customers on time. How does that normally look like? Well, first it starts with, of course, either a client specification or request for changes or new features or new things. After that, we should, of course, we plan it. We say, yeah, we can do that. No, we can't do that. Then it goes to the development. This is point 3. After the development, yeah, of course, this code has to be reviewed, tested. Then we deploy it to the client. Client then starts using it. We have to support him with that, and of course then there is going to be some bugs, some issues, some ideas, and the circle continues. I guess of course we're going to talk about agile development. I guess everyone now is doing it. I guess you've seen this slide before. Basically how it works is just basically that we have a number of sprints which are always based on the product backlog. When this thing is done, after 2 weeks, 3 weeks, it goes to the release, and then we have to again handhold our clients and make sure that clients are happy, which means we have to organize our complete project management around our clients, our customers. So one of the main thing about release management is, of course, source control, version control. Why is it so important? Well, first, it always enables us basically to do the development in parallel. So whenever there is any kind of a serious project, usually it's not done by one guy. Usually there is always a team involved. And without version control, there is absolutely no way that we the code in parallel and make sure that the whole thing is going to work at the end, and that it's going to be safe to deploy to the client. Secondly, it enables us always, whenever we screw up something in the code, it always enables us to go back and recreate any earlier version of the code. This is important either because of our let's say mistakes that we revert to certain things, or that our customer might be using a version from, I don't know, half a year ago, and customer does not want to update his system to the new one, because you know that all updates are always evil, but he wants to have a fix for the version that he's using 6 months ago. Of course, version control is exactly a perfect tool to enable you to go back in time to recreate any earlier version that you might have deployed to your customers. Of course, it also enables us to control all the changes that are happening on the source code. This is especially important if you have some juniors in your team which are posting some code which, let's call it, could be suboptimal, just to make sure that everything that goes into your main branches, the code is good code, is really code that should go in there, not that some rubbish finishes in the final version. And of course, yeah, it enables us to have fully distributed teams which could work in one office or in 10 of them in different countries. Talking about version control, let's talk about history. Well, all of you, let's say, aged or seasoned developers, remember the time when we had traditional version control, which was always server oriented. We had the server package installed on our server, and then we had to pick up some source code file that we wanted to work on. This file would be checked in separately, locked, that nobody else can work on it. And then whenever we were done, we would then copy it back to the thing and unlock it that somebody else could do it. Of course, because this is reserved kind of a checkout, no way that on the same piece of source code 2 developers could work at the same time. This is why this thing changed into distributed world, which is fundamentally the time when fully work in parallel was enabled. Before that, it was all cumbersome and yeah, it was very, very hard time. For maybe some of you older there, if you remember working in tools like SourceSafe, you don't want to go back to this, okay? Basically, it allows us that everybody's got the copy of the complete repository, that everybody can work on his own version of the source code, and then instead of locking different files, when files are done, we try to merge them. Of course, more merges are done, easier it gets, because longer you wait with the branch to be merged with the main branch, more conflicts, more, let's say, issues might happen. Of course, this also means that there is that there is no need to communicate when if you want to work on a different piece of code with the server. You have a copy on complete source code on your PC, and each and every of the working copies on each developer's PC straight away a backup of your repository. Of course, these repositories with years could become very, very, very large. We have such thing. It's enormous. What version controls, yeah, are popular? Well, first it's Git. Of course, you know all Git. I think Git at the moment's got like 75% of the market share. Then there is still good standing SVN, which was, yeah, previously the top one, but then Git slowly is taking over. There is the Mercurial, there is Visual Studio, versioning control, there is a CVS, Fossil, various things. But in a nutshell, all these are distributed systems. And in a nutshell, whatever I'm going to talk about Git would apply basically to any of that. So whatever you use in a company, in your company, what I'm talking now is going to apply more or less to any of these tools. So how does Git works? It's really a rather simple piece of software. Basically, it copies the files from repository to your local drive, and at the time when you are done, it just does the file compare of what you did and what is in repository, and then merges these changes. It just does that. Basically, what is always strongly recommended, this repository, of course, you can have one on your local workstation, but it's always good to have a remote repository. Why? Well, first, it of course enables you to work with your colleagues in parallel on the same project. You don't need, it doesn't have to be a special server, it could be just some shared drive wherever. Okay, it every of these pieces of source code that you commit, straight away whenever you commit, has got basically also a backup. If your PC dies, there is a backup on the network, or if network drive dies, you have a copy on your local drive, so you cannot lose any of your work that you've been done. Let's talk a bit about concepts. And how does this complete branching works? Well, first concept that I really fully recommend is to store absolutely everything under version control, not only source code. Why is that? Well, a lot of people are just committing to the versioning system just their C# files and maybe project files, and that's it. That's bad, because then you have to keep all the other files somewhere else. You have to back up all the other files somewhere else. When the new guy comes to your company, you cannot just check out the complete source code. If your PC dies, you have to, even if you don't work in a team, if your PC dies and you have to load in everything to a new PC, yeah, you have to dig everywhere. And what is important is it doesn't really matter, okay? Because you're gonna copy, let's say, even various DLLs, even the various things which are needed to compile your system. You're gonna copy them to your repository only once. It doesn't matter that complete package is, I don't know, 50 mega. With every new commit that you make of your source code, it's not going to save 50 mega. It's just going to save this a couple hundred bytes of the delta between what was committed first and what is committed now. So it's not going to overload your server. It's not going to do any harm anywhere. On the other hand, you can always easily make, let's say, full build with one push of a button. You just check out the latest version of your source code, and then you make make file, and complete product is built. Branches. First thing to remember is branches are very cheap. Again, do not hesitate ever to create a branch for anything new that you are doing, and you might think that it's better not to mix with somebody else's work. Creating a new branch on Git does not cost you anything, basically. There is like 5 bytes that's going to be written somewhere, and this is going to be just the branch name that you created. Only the differences, again, only the delta that you newly coded for this branch is going to take some place. So absolutely, there is no reason not to go into your branch whenever you're going to work on something that you know it's not going to be finished in like 5 minutes, or that might take some time to be done, but you still want to commit things all the time, not to lose anything, also to have a track. So whenever you are working on any kind of slightly non-trivial feature, always open a new branch. Okay. What is very important is to commit as often as possible. This of course means that sure, whenever you commit, if this is something that's get committed to the main branch, of course this must be a finished version, something that's working, not to break the build for anyone else. So tag where always commit very often, and always tag every commit with some name, with some description. Okay, because this is got a number of advantages. First, of course, you can know exactly what you did when and why and how. Secondly, you can easily go back to the version that when something was working, which is not working anymore. And of course, it is sort of a documentation of your source code, because once when you have this is, for example, this is our live production screenshot of our commits. Okay, so what you can see here, we always write what's been done. But what's cool about this is that later on in the source code, you can actually see these commit messages next to the lines of your code. So even if you don't comment a certain line of a code, when you hover over it, you can see, aha, this is done to fix AQA fact sheet bug. You straight away know why somebody that this line of code was written by Mario, and that he did this line of code in order to fix this bug on the fact sheet. Without the notes, you're gonna just need, aha, Mario did that, when you do the blame kind of the thing, but you have absolutely no idea why he did it. So this is why it's essential, whenever you do commit, put the message there, commit often, because then first you remember what you did, and secondly, it's much safer. Now, branches. There are different ways how to organize your branches, how to work, how the release management works. We're going to show you a couple of them now. But in general, there are all have something which is like a master branch. It could be called a release branch. It could be called whatever. But this is basically the branch which is always containing fully working version, the version which we deployed to our customers, the version which we know should be, yeah, let's say, bug free. Okay. Then we have our dev branch on which all the developers are posting changes, and of course this one is not fully tested, not fully working, not something that you would normally give to your customers, not something that you're going to put in production ever. Okay. Then we have feature branches, and this is when, as I said, there is a feature which is not trivial that has to be developed in order to be able to commit, often, and in order to be able to maybe later on decide whether this feature is going to go into the product or not, always then create separate feature branches for this parallel work on them. And yeah, there are some release branches, which is usually just used when we have to make kind of a bug fixes for our normal release. So on one side we have the master branch. This master branch from time to time gets synchronized with our development branch. Also, we could have, as I said, various branches for the different teams in our company. We can have feature branches, and of course there are yeah, always hot fixes, bugs, things like that that we have to work that, you know, on directly on fixing our main master. This is the nutshell, common to all different release management scenarios. This is great how it looks, yeah, on this slide. But you know, quite often if you run a project and then you take a look at it, then you get a branching something like that. This is more common. This is like real life how it looks like when you say, yeah, please show me the tree of of our branches. It looks something like that. So in order not to be like that, let's talk first about trunk-based branching structure. In trunk-based basic structure, the master is basically the main and I would say the only only branch that we run all the time. Then on this master, we're gonna do the bug fixes in the separate branches. When the bug fix is finished, we're gonna commit them back to the master. We're gonna also open various feature branches, which we're gonna copy back, and different bugs and features and bugs and features. And not all features have to finish up in the master. We might drop some in the time. So this is fine, but of course this is, as I told you, very risky, because you have to make sure that every commit that goes to the master finishes up in let's say ready-made code that could be deployed. That this is really ready for you know, for the release. So this is very simple, very easy to work with. But yes, you have to be careful that there are no big bugs in it, that there are no untested things before you release it to the customer. Bit better one is release flow branching. Release flow is the same like the previous one, like a trunk-based branching, but the main difference is that from time to time, when we know, now we are now done, we then open a release branch. Here it's this branch, let's say M120 version 120. And in this case, we then go from the master, we open the new branch, and then this branch, M120 or later on M121, is the branch on which only bug fixes go later on. So it goes to the release branch, and then in this branch, this goes to your for testing. Testing first internal, then you give it to the client, let him test. Of course, he paid for it. Okay, so and then during this testing, there's going to be bug fixes. These bug fixes are going to go in release branch, but never ever new feature. If there is a new feature, that goes to the master, and then it's going to finish in the new release. Come on. The other very popular branching structure is Git flow branch. Again, Git flow, don't get mistaken. It works with Git, it works with any other. It doesn't have to be, you know, Git doesn't have to be the version control. This is just called Git flow as the structure name. So what is the difference here? Well, here we have our dev branch. The dev branch, as such, basically contains the code you are working on, and this dev branch gets initially copied from the master. There we do various features which we later on merge back to the dev. There also of course could be hotfixes, and these hotfixes are always then going to a special, let's say, hotfix branch. In this case, whenever we are done with the hotfix, we're going to commit this hotfix to the master branch, but we need also, of course, to copy it to the dev branch. This is mega important because, yeah, what could happen, and it happened to everyone, including us, is that yes, if this is forgotten to copy the hotfix to dev, what happens? What happens is that the bug that was fixed in version 1.1 resurrects in version 2 because, yeah, it was not in the dev branch. So this is why it's very, very, very important that all hotfixes are later on merged with both master and development branches. Then, okay, let's say after some time, we say, yeah, now the thing is ready. And we then start with the release branch, this black one. Again, the similar like with release flow. Then once when it comes to the release, then we do not do any new development into it. If you look at this at the arrows are only going from the release to dev. So basically here we are doing only bug fixes of this release. So every bug that we find there, we copy back to dev. Every bug has to be merged back to the dev. And then when things are fully ready, then we merge it back to the master, and that becomes then our new version. That becomes our production thing that goes to the client. Now, this would be great in a perfect world, but the world is not perfect. And again, there is always a case that we are already in the version 2.0, but the client's got version 1.1 and reports a serious bug. And again, client does not want to do the update to version 2 because that would require his team to do the new testing. It needs a complete procedure, and they need this report by Thursday, and you have to do the patch. You have to fix it straight away. Yeah. Then you in Gitflow open so-called support branch. In this support branch, you basically then make a copy of this version, let's say 1.1, and then support branch becomes the special, let's say, branch in which we have support branch for version 1.11. So it's from version 1.1. Once when we fix the bug, it's going to be version 1.11. But then again, you have to be very disciplined, and then this change that you've just made in version 1.11, you have to copy back to dev. And of course, you sooner or later have to fix this bug also in the version 2.0. So you have to merge it with both, with your latest master and with your dev branch. Okay. Now, one very important thing here is that what is important for what is important for, let's say, especially for Git flow, is that very, very common for the Git flow is that changes are not directly merged to the branches, but there is something called pull requests. Everybody that works in open source is very familiar with pull requests. Guys working in some of the other companies might not fully understand what it is. Basically, what pull request is that instead of pushing straight away the branch to the server, there is just a developer just sends the list of changes as a pull request, and then somebody has to review these changes before they get merged to the branch. This somebody is usually a senior developer in the company that needs to check out what has been done. Does that make sense? Is the code okay? And then if not, then write some comments, send back the thing to the developer, say please fix this and that, and please, there is a very unclear code here, please rewrite. And then he would do it. He would do another pull request, and then when then the senior developer say, yeah, that is fine, then this thing goes to the branch. This basically is very good for, I mean, this is essential for open source project. None of the open source project could work without this kind of the structure, without this kind of routine of the pull request. Secondly, it is very good if you have any junior developers in your company. It is good first to make sure that your code is stable, that your code is fine. And secondly, this is also kind of seamless training of your juniors, because I mean, the junior has to be reasonable and not to take it as the critic from the senior developer. But basically, he learns a lot from the changes that senior developers proposes to be done on these pull requests. And with every new pull request, junior developers learn something new and basically evolves during time. And thirdly, it is great because you have the full control of what goes into your product. If you have a mature product that you're running, then of course you have to be super cautious not to break something that was working for years for the clients. Clients usually get rather pissed off when something was working before the update and now it doesn't work anymore. This is one of the main complaints we hear from our clients, that they don't want to update because something is not going to work well. So this is why pull requests and GitHub is very important. Now, how does that whole thing work in practice? Well, usually, yeah, there could be, it is great. On the other hand, if you need to make a lot of quick changes, if you're just starting with the project, let's say you're a startup and the thing is being developed very fast, then it's much better to go to this trunk-based or release management kind of the track, because then everything goes to the master. There is no slowdown, because you understand, if you have like 10 different commits during the day, your senior developer or developers have to spend significant time, their time, analyzing what goes in. Quite often they are busy with something else, and then the code stays there, and then there is a slowdown, and then the junior developer doesn't know what to do now because he's waiting for the feedback, and it could really slow down. So this is why for kind of a quick development and a startup, and before you come to this minimum viable product kind of a phase, it might be better just to go trunk based and then just dump everything into the master, then do the testing, then do the thing like we discussed initially. And secondly, if everybody in your company is a senior, then it might be that your seniors are very reliable, and the code that goes into the branch is really already kind of reviewed by themselves, and they know that what's going in is a thing. And what happens very often is kind of a combination that in the team, code that goes from the junior gets pulled by senior developer that does it. But on the other hand, what's very often in various software companies around is that senior developers have permission to basically authorize their own code. This is the common scenario in a lot of the companies, where basically senior developer does the audit of his own code and say, yeah, this is cool, this is great code you wrote, bravo Bernard. This is common scenario. It's bad scenario for sure. it should be the different senior that is going to check it. But yeah, in real life, this is what happens all the time. Now this was all kind of a theory. Now let's talk about how we do it in our company. In our company, our clients, of course, asked us to provide them with, our release management kind of the rules. And this is what we tell them. We tell them first that there's going to be every year, let's say, 4 main releases, Q1 to Q4, quite easy for them to understand. We say that we have like bi-weekly sprints development, and by the end of every bi-weekly thing, there is like a new version going out. We always, of course, have development and releases versions in parallel, like we just discussed a moment ago. We try to practice a peer review of changes. We don't do pull requests, but we do peer review, which is basically, yeah, we can commit to our development branch, whoever can commit, but all these changes get reviewed sooner or later. Okay, so that in case that we see that somebody committed something which is rubbish, then it could be easily reverted. Release versions, of course, needs to be fully tested before giving it to our clients and saying that the Q1 is ready. And absolutely no new features is ever in release version, only the bug fixes. Okay, any new development goes in dev track or in various feature tracks, and we quite often tell the clients what is coming in the next version, what is the feature set that's going to be in the next version. And there we basically take the backlog, and then we always take, let's say, 40% of feature requests coming from a client, and we try to make, let's say, 40% of our time for our strategic development. So clients, don't know what they need. Okay, we decide on that, and 20% we always have to reserve for incidents, emergency support, because every day there are calls from the client because something or other is not quite like it should be working. How does our branching works? Well, this is a combination between Git flow and release-based management. So this is, yeah, something kind of in between. We have our dev branch and our release branch. So whenever we say that thing is ready, if we go into release, this release again, gets only updated with the bug fixes. Features go in parallel to the dev branch until we come to the version 2. Then this version 2 gets bug fixes, comes 2.2, 2.3, and so on. And like you see, the last feature branch here finishes with X. Why? Because we might at the end decide that this feature is not working like it should, or that it does not make much sense, or that it's going to break something, or that it's going to be, basically not very welcome to a client. And then some of the branches unfortunately finish in some of the features finish in garbage. Now this looks nice, but unfortunately there is always again special client saying that they need a patch on version 1.1, even though we are now 2.2, and this is why we have so-called patch branch, on which we just do patches for our special kind of the client asking for the patch on the version Q, let's say here on the version Q 1.1. This is how we work. This is what I've shown you before in these commits. Cool. So now let's just talk about some nice things in Git. For example, one of the greatest thing is Git blame. Basically, it allows you to see who did which line of code. So who you're gonna blame. Easy. Every line of code you can see who did it in which release, and then you look at the notes and you see why this has been done. Okay. Then secondly, there is something called Git bisect. Basically, what it does is that you don't know when something was broken. You just know that it was working in version 1.0. In the version 2.0, it's broken. And then simply by dividing, let's say, our repository in half, with, let's say, kind of the binary tree structure, we go out and see, what was the last version that's been working. Okay, this is quite useful. Then there is a concept called cherry picking. Okay, which would allow you, that maybe some of the things that which were in the feature branch are working fine, some not, and then you can really cherry pick and take just part of the of particular branch and merge it with your dev branch. This is sometimes useful. On the other hand, it's quite dangerous. So I do not recommend this thing. Then we have also something called git stash, because very often it happens that things are being committed to the wrong branch. I was telling you, open as many branches as possible, always open a new branch, it's great. Well, it's not so great when you forget on which branch you are and on which branch you have to commit something, and this allows you to basically apply them also to another branch. There is also kind of git reset, which allows you to revert everything and go back to the working state, whatever the last working state was. Okay, great. Now, here are some resources. I'm going to share this PowerPoint with you guys, so you don't have to copy this thing. So this is things which are quite useful to see how Git flow is working, how various release management things are being done. And with that, I'm going to finish this session. I want to once again to thank you all. Thank you. And I'm going to switch to Birtia if you would like to discuss anything. But anyway, now we have 2 more minutes. Are there any questions now, or shall we go to Birtia? Any questions? No? Then thank you very much, guys. See you then in Birtia. Cheers.
Hvala ti, Beri.